We've already reviewed the first half of geometry. We did Venn diagrams, we did conditional probability, all those given problems. We did the two-way tables, conditional probability. And today we're going to review the second half, that is independent events, dependent events, overlapping, and mutually exclusive events. So a bag contains 5 red balls and 3 green balls. You randomly draw one ball. Do not replace it. Do not replace it. And randomly draw a second ball. What is the probability that the first ball is green and the second ball is red? Well, we have 8 total balls in the bag, and we're going to draw one and not replace it. Okay. What's the probability that the first ball is green? We have 3 green balls, and the second ball is red. Well, we took one ball out, we didn't replace it, now we have 7 in there. How many red balls are in there now? There's still 5. That'd be 15 out of 56. Next one. A teacher has 4 red apples, 7 yellow apples, 5 green apples in a bucket. This was kind of a problem that was in your notes. Maria will choose 2 apples at random without replacement, so she's not going to replace. She's just taking the apples and stealing them. What is the probability that Maria will choose a yellow apple and then a green apple? So how many total apples we got in that thing? 12, 16 total apples. And then we've got how many are yellow? There are 7 yellow. And then she didn't replace it, so she kept it out. There's now 15. And then a green apple. There are 5 green apples in there. 7 times 5 is 35. 16 times 15 is 240. That will reduce. I know some of you don't have a good calculator that'll reduce, so I'm just going to leave it as 35 out of 240. Number 3, we've got a teacher with 7 red apples, 2 yellow apples, and 1 green apple in a bucket. We got 10 total apples. Okay, 7 plus 2 plus 1 is 10 total. Maria will choose 2 apples at random, replacing the apples after she picks them. What's the probability she'll choose a red apple? Well, 7 out of 10. And then a green apple. Well, we picked the red apple, put it back in. We still got 10 in there. And there's 1 green apple. Be 7 out of 100. Number 4, you write each of the letters of the word football on pieces of paper and place them in a bag. How many letters we got? 1, 2, 3, 4, 5, 6, 7, 8 letters in the word football. You randomly draw one letter. Do not replace it. Do not replace it. This would be a dependent event. Then randomly draw a second letter. What's the probability that the first letter drawn is in O? How many O's we got? 2 out of 8. And then the second letter is an L. All right, we didn't replace it. That means now we only have 7. And then we've got 2 L's. That would be 4 out of 56. That reduces. I'll let you reduce on your own. I know some of us don't have a good calculator. Number 5, we have a code consisting of 2 digits followed by a letter of the alphabet. What is the probability that the code is 83X? Well, I have 3 different characters in my code or my password. And what's the probability that the first one is an 8? 1 out of 10. What's the probability we get a 3? 1 out of 10. What's the probability we get an X for our letter? 1 out of 26. Multiply those, that's 1 out of 2,600. And I made the point to, I think Claire the other day, that if this had said different up here, different digits, then this would be 1 out of 10. This one would be 1 out of 9. Okay? And it doesn't really matter what your code is. This could be 3-4A. It'd still be the same probability right here. What's probably getting a 3? What's probably getting a 4? What's probably getting an A? Same thing, okay? Number 6, a code consists of 2 different digits. There we go, different digits, followed by 2 different letters. Different. What's the probability that the code is 14AB? So we have 4 characters in our code, and the probability that we get a 1 on the first one's 1 out of 10, but it needs to be different digits. So this one would be 1 out of 9. Okay, 2 different letters of the alphabet. First one's going to be 1 out of 26. What's the next one going to be since it's different? 1 1 out of 25. Multiply all those things together, and it will give you 1 on the top, and then 58,500, I believe. Hopefully that's right. All right, let's slide it over. In Miss Briscoe's class, there are 13 boys and 12 girls. On this particular day, 4 boys and 5 girls were crying. Number 7, if a student is chosen at random from Miss Briscoe's class, what is the probability of choosing a girl or a student who is crying? Key word here, or. Or tells me I'm going to add. What's the probability of choosing a girl? Well, we've got 12 total girls out of 25 total students. Or means add. A student who is crying. Well, how many kids we got crying? 9 kids crying. All right, so we've got 12 out of 25, and then we've got 9 out of 25 students crying. Is there any overlap there? Are there girls who are students who are crying? Well, we've got 5 girls that are crying. Girls, students are crying. That's the overlap, minus 5 out of 25. 16 plus 9 is 21. Minus 5 is going to be 16 out of 25. Next one, we got, what's the probability of choosing a boy? All right, we got 13 out of 25 are boys, or means add. A girl who is crying. We've got 5 girls that are crying. Is there any overlap there? Are there boys that are girls who are crying? No, there's not. 18 out of 25. Okay, number 9. What's the probability of choosing a boy? We said there are 13 out of 25 are boys. Or means add. A student who is not crying. Here we go. We've got 9 people who are crying. So 9 out of 25 are crying. How many are not crying then? Well, you could just say 25 minus those 9. That would mean that there are 16 people who are not crying. Okay, so let's go back down here. Students who are not crying, 16 out of 25. Is there overlap there? Are there boys who are students who are not crying? Sure, there are boys who are not crying. Let's go up here. There are 4 boys who are crying. That means that there are 9 boys that are not crying. Minus 9 out of 25 that are not crying. I believe that that would be 20 out of 25. That will reduce. We're not going to reduce it here for those of you that don't have fancy calculators. Okay. Number 10. What's the probability of choosing a girl? Girls would be 12 out of 25. Or means add. A student who is not crying. We just did that. Student who is not crying up here. So that was 16 out of 25. All right. Is there overlap? Are there girls who are students who aren't crying? Well, let's go up here. We have 5 girls out of 12 girls are crying. So how many are not crying? 7. Okay. That would be 28 minus 7 is 21 out of 25. Last one on this side. We got, what's probably choosing a boy who is crying. Boys that are crying is 4 out of 25. Or means add a student who is not crying. All right, we've already said that. We've got 16 that are not crying. Are there crying boys that would be counted as students who are not crying? No. This is 20 out of 25, and that would reduce, but we're going to leave it like that. Let's flip it over on the back. All right. What is the probability? All right, first of all, Jimmy, my boy, has a number cube, a die. Multiple would be dice. With sides labeled 1 through 6. He rolls the number cube twice. What is the probability that the sum of the 2 rolls is a prime? That should be a prime number. English check there. What's the probability that the sum of the 2 rolls is a prime number? Given that at least one of the rolls is a 1. Given that at least one of the rolls is a 1. That means I'm only going to look at the ones with a 1 on it. So we got our number cube. That'd be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 3, 1, 4, 1, 5, 1, and 6, 1. Okay. How many total we got there? I believe we got 11. And then we want the sum to be a prime number. Okay, so the sum of these would be 2. And several of you missed this on your little graded assignment last time. 2 is a prime number. 2 and 1 are the only factors. 3's a prime, 5's a prime, 7's a prime. So we got 1, 2, 3, 4, 5, 6, 7 out of 11. Okay? Let's do number 13. What's the probability that the sum of the two rolls is an odd number, given that at least one of the rolls is a 1? So, we would circle all the ones with a 1 on it, just like we did up there. We're going to write all those again. So, given that at least one of the rolls is 1, I got 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. If it had said, given that at least one of the rolls is a 5, you would write 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. On and on. Do the same thing except with 5s. You wouldn't write 5, 5 twice. Anyways, given that at least one of the rolls is a 1, we want to know what's the probability that the sum is an odd number. There are a total of 11 ways right there. And how many ways can we get a sum of an odd number? Those would equal 2. Those would equal 3, 4, 5, 6, and 7. 3 is odd, 5 is odd, and 7 is odd. 1, 2, 3, 4, 5, 6 out of 11 ways. Let's slide it over here. Number 16, we got Timmy in his number cube. He's labeled 1 through 6. He's going to roll it twice. What is the probability that the sum of the two rolls is less than 4, or, means add, at least one of the rolls is a 3? Well, how many ways could we take 2 dice and roll them to get less than 4? Well, we could get a 2 and we could get a 3. I don't think we could roll anything less than a 4. You can't roll a 1 because you got 2 dice. So I could roll a 1, 1, and I could roll a 1, 2, and a 2, 1. I think that those are my only options for something that is less than 4. Okay. The next way, so we've got what, 3 out of 36 right there. Or means add. Or at least one of the rolls is a 3. So that's similar to what we were just doing with the 1s over there. So we got 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, and 1, 3, 2, 3, 4, 3, 5, 3, and 6, 3. How many total ways can we roll at least one of them with a 3? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 36. Next question is there any overlap? Is there anything over here that's over here? Well, all these have 3s in them. None of those have a 3 in them. No overlap there. That would be 14 out of 36. That would reduce to 7 over 18. We're not going to worry about that though. Okay. Let's look at the next one. Number 17. What's the probability that the sum of the two rolls is a prime number, or at least one of the rolls is a 3? All right, so prime numbers I can roll with 2 number cubes. I could roll a 2, I could roll a 3, I could roll a 5, I could roll a 7, or an 11. I think those are the only prime numbers I could roll with 2 number cubes. I could roll a 1, 1, 1, 2, 2, 1, 1, 4, 4, 1, 2, 3, 3, 2, 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, 4, 3. 7 is lucky because it shows up more than the other ones. That's the only reason it's lucky. All right, so how many total ways is that? I think it's 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 36 ways you could roll a prime number. Or at least one of the rolls is a 3. So at least one of them is a 3. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 1, 3, 2, 3. Oh, don't do that one twice. 4, 3, 5, 3, and 6, 3. I believe that's a total of 11 ways right there. And then you need to find any overlap. Is there anything over here that shows up over there that we've already counted? We don't want to count it twice. So all these have 3s in them. I'm going to come over here to anything with a 3 in it and subtract. 1, 2, 3, 4, minus 4 out of 36. That would be 22 out of 36. That would reduce to 11 out of 18, but we're not going to worry too much about that right now. Last one we're going to do on this one. Number 18. What is the probability that the sum of the two rolls is an even number, or, means add, at least one of the rolls is a 1? So how many ways could we roll an even number? I could roll a 2, I could roll a 4, a 6, an 8, a 10, or a 12. Okay, so I could roll a 1, 1, I could roll a 1, 3, 3, 1, or a 2, 2. I could roll a 1, 5, 5, 1, 2, 4, 4, 2, or a 3, 3. All right, 2, 6, 6, 2, 3, 5, 5, 3, or 4, 4. Could roll a 4, 6, 6, 4, or a 5, 5. And then I could roll a 6, 6 right there. Spoiler alert, it's going to be 1/2, 18 out of 36, because half of them are going to be even. So it's good to write this out because we're going to mark them out here in a second. It's going to help you know which ones to cancel. So if you recount those up, you get 18 out of 36, or means add, at least one of the rolls is a 1. So at least one of the rolls is 1 would be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 3, 1, 4, 1, 5, 1, and 6, 1. That would be a total of 11 ways. Is there any overlap? Is there anything over here that shows up over here? Well, all these have 1s in them. Anything over here with a 1, we're going to subtract. 1, 2, 3, 4, 5. Looks like it. 5 out of 36. That would be 24 out of 36, which would reduce to 2/3. But we're going to leave it like that.